Okay, so today's lesson, the purpose of today's lesson is that we are going to learn how to graph an inequality on the coordinate plane. We've been graphing inequalities on the number line, and so now we're going to do it on the coordinate plane. When we first started, when I gave you x is less than or equal to 3, we put this on a number line, and we made sure to have 0 in the number. And we started at 3. What kind of circle did we have? A solid circle. And then we went in the direction where x is less than 3. We would go left, to the left. When we're on the coordinate plane, this is kind of like the equation. It's kind of like x equals 3. And I told you guys I'd like you to make a little table. It's saying consistently that x equals 3 and y, we choose our y's. So I'm going to choose 0, 1, and 2. And then I plot those points. Another way to look at it is this is a number line right here. And I still go to 1, 2, 3. Right? And that's a point. I can also make another point. It's 3, 0. Here's 3, 1. And when I start seeing that pattern, again, I'm going to draw the line. You with me, TJ? So now, isn't that the same thing as x equals 3 equation? Yes. Okay? Okay, just listen. Okay? Do you understand how to graph x equals 3? So temporarily, we pretend it's an equation. Now, the shading. Where are the numbers less than 3 on this number line here? Is it on the right side or the left side? So then we would shade that entire side. You could do a colored pencil, you could do a pen, you could do a highlighter. Doesn't matter what you do it with. Shh. So, meaning, what this really means is that so we're shading that. And what that really means is that every single point in this shaded area is a solution. Meaning, I could take this point right here, 0. When x is 0, is that a true statement? Yep. When x is, because I'm really not utilizing that y, right, in that ordered pair, every single point, including all these points inside here. There's so many we can't list them, and that's why we shade. Remember when you guys were doing the Desmos and you said, how do you shade? How do you shade? What do we shade with? The inequalities. Yes, Bryce?
So would it be you can go infinite as far as you want, down, up, and to the left? You couldn't go anywhere, right?
I'm confused with that question.
Like, so on a coordinate plane, you could extend your shading anywhere up, anywhere to the left, and anywhere.
Right. Well, these have arrows. That's what that means.
Oh.
Okay. The arrows mean that yes, this goes on and on forever. The shading and the line forever. Yes.
And are those two the same? The number line and the coordinate plane?
This is on the number line if you ask to grade it on the number line, and this is how we graph it on a coordinate plane. Okay? All right? So let's continue. When we have y equals -2, I'm going to remind you on the number line, in this case, we just went to -2, and this time, is it a solid or is it an open circle? Open. And then we go in what direction? To the right. Okay? And on the coordinate plane, again, we're going to treat it like it's an equation. We make our xy table. And y is -2, -2, -2, and I do 0, 1, 2. So I start here, and here, and here, and then I draw my line. Now, which way are we going to shade? Okay, so now we take our number line, just like on our number line when we have this open circle, okay, because it shows it doesn't include the -2. On the graph, we show that it doesn't include -2 by making it a dashed line. So that means it's all numbers greater than -2 but not including. Now, where do we graph? Look at what it says. Read it, everybody. What does it say? Y is greater than -2. On the y-axis, where are the numbers greater than -2? Above. So that is the area that we shade. Okay. Yes?
Why do you, wouldn't it be different for like or equal to? Because then that could equal.
Then what would happen is if it were equal to, the boundary line would be solid. Okay? Where if it's just greater than or less than, it's dashed.
Oh, I see.
It's the boundary line that changes. Annabella. Okay, first of all, there's a little... So the question is, why do we shade upward? Because this says y is greater than -2. So if this is my y-intercept is at -2, where are the numbers on the number line greater than -2? This is -1, this is 0, 1, 2, 3, 4, and this is -3, -4. Do you understand? So the numbers are greater above that point, and that's why we chose that. Dakota?
So if it was y less than, it would be
Below the line, correct. So let's try a couple. Go, Carter.
I was just wondering, can it be like, can there be like both x and a y in it?
We're getting there. We're getting there. Go.
So like shading wise, it doesn't matter if it's like greater than or equal to?
Right. Shading wise, it doesn't matter if it's greater than or if it says greater than or equal to. The equal to makes it solid line boundary, and the greater than makes it dashed. All right, so now we have two variables. We're going to treat this temporarily like an equation. When you graph an equation, what do you have to do? Right, and what do I have to find?
M and B.
M and B. And so my M price is?
2/3.
And my B?
-1.
-1.
So you start at -1 on the y-intercept.
Good. I'm starting at -1, and then I'm going to
Go up, rise 2 and run 3.
rise 2, run 3. Rise 2, run 3. Or
You can rise -3, or rise -2 and run -2.
rise -2, run -3. And now, go back to this. What kind of line are we using? Will it be solid or dashed? Solid. So it's going to be a solid line because it's or greater than. And then I'm going to draw my line. Oh, that's ugly. Here we go. I'm going to draw my, whoa.
Oh, God.
It's not letting me draw the line. It's like, I don't know why. I'm going to use this. Okay, so it's going to be a solid line. Now, the shading. I have a little trick that I do. My shading trick is I go to the y-intercept in the equation, right? The y-intercept is when x equals 0, right? It basically makes this term disappear, right? If x is 0, we can block that out, right? You guys with me? Okay, and now read it. What does it say?
Y is less than or equal to -1.
So go on your y-axis. Where is, from that point, from this point, where is the less than or equal to, the less than numbers on the y-axis, above or below that point? Below. And so that becomes the area that gets shaded.
Wait, but wouldn't
Yeah.
you not shade above the 2? The -1?
The boundary line in my little method is find your y-axis, your y-intercept. It's right here. Numbers that are below less than -1. Here we have -2, -3, -4. This is 0, 1, 2. Where are the numbers? Are they above or below that point?
Below.
And that is the area you shade, below the boundary.
To the right, it goes higher.
It doesn't matter. The y-intercept, I'm asking you to look at the y-intercept. Okay? So, I'm going to keep going, and then you'll see if that question gets answered. I'm going to keep going, and we'll see if that question gets answered. So, there is another way. The other way you can do it is you can pick a test point. A very easy test point is the origin, 0, 0. We can take that test point, substitute it in. If this is a true statement, then that is the side you shade on. If this becomes a false statement, then you shade the opposite side. Now, this is the way the book's going to teach you to do it. So again, and now when I simplify it, it's 0 is less than or equal to -1. Is that a true statement or a false statement? False. So that test point, I do not shade that side, I shade the opposite side. Do you understand? If it's a true statement, you shade the test point side. If it's a false statement, you shade the other side. Okay, yes, questions? So the question is, how do you choose a test point? You can choose any point. So because this equation is y is less than or equal to x, no, 2/3 x, 2/3 x minus 1, I might choose, like, I want to choose an x with 3 in it, right? So 1, 2, I'm gonna choose this as a test point. So that's 3, -1. So I'm doing -1 is less than or equal to 2/3 times 3 minus 1. So if I simplify this, if it comes out true, I shade that side. If it comes out false, I shade the other side. The other side of the line where the test point is. So this time I'm choosing a test point on this side of the boundary line. So if it comes out true, that is the side of the boundary line I shade. So now I get -1 is less than or equal to 2 minus 1 is 1. Is that a true statement? Is that a true statement, Rami? So since that test point is on this side, this is true, then I shade this side of the boundary line. Yeah.
But I'm probably wrong. But why can't you just see that it's less than and go down? Because I'm trying to. Like,
That's what I'm doing.
No, but like.
That's what I do with my method.
I know, but you're.
So our test point, if it works out to be true, then you graph that side. If it turns out to be false, then you graph the opposite side of the test point. Yes.
I'm confused why we need a test.
You don't need it. It's one method. I showed you one method. That was my method. Or you can use a test point method. You have to have a way to figure out which way to shade. Okay? I don't like to copy the boxes because I always can't remember, is it left, is it right, is it up, is it down? So I just make sense of my y-intercept. Okay? All right, let's try this one. Pause the recording and you guys try graphing this one. Let's try it. Dakota, what's my M?
The M is -1.
Good. And what's my B?
3.
Good. And where do we start by graphing?
You start 3 on the Y
Axis. Good.
and then you go -1, 1,
Down 1.
down 1, over 1,
To the right or to the left?
to the left.
If you go down 1, you have to go to the right one because it's negative, positive 1. -1, then positive 1. -1, then positive 1. Otherwise, if you do negative in both directions, you'll end up with a positive slope. Okay? Okay, now, or I can go positive 1, go up 1, left 1. Okay, now I'm drawing my line. Will it be, Rami, will it be solid or dashed? It's going to be dashed. I don't even use my straight edge. I just take these points here and I just kind of like, I just draw little lines through them, right? Shh.
Oh, I did a line and then it just erased.
So, but you do need arrows. Now, Bryce, which way am I shading? Above or above the line, because it says y is greater than positive 3. So all the numbers on the y-axis are up here. Questions? Yes.
So I get all of that, but like going back to your method, why do you need to know what like the y-intercept is to shade in? Because like you know it's greater than, so it's greater than it's up.
Okay, so that's fine. Whatever you need to do.
Wait, but that's what I just said, and you showed me one at a time.
Well, if you can't figure that out, if your method works, okay, let's try the next one. You're basically doing what I'm telling you to do. Okay, I'm going to skip this one. Okay. What happens if the equation is not in slope-intercept form? We still have to change it. So what am I going to do first? Go, Veronica.
Well, would you like have it be the like so it'd be like 3x minus 2y equals 8?
Yeah, but what am I going to do first?
Subtract 3x from both sides.
Subtracting 3x from both sides. And then
Divide both sides by negative.
all terms by negative 2. All terms by negative 2. Pay attention. Okay, now what?
So then you would have y, and then is greater, or is less than. Yeah.
Is less than. Why are we making it less than?
Because you're divided by negative.
Right. So I end up with,
Is less than 3 over 2x minus 4.
minus 4. And my m is 3 over 2. My b is negative 4. We start at 1, 2, 3, 4. And then I'm going to rise. 1, 2, 3, run 1, 2. 1, 2, 3, run 1, 2. Finish it up.
Rise up 3, go to the right 1, 2.
No, you finish it up on your... Is this a solid or a dashed line?
Dash.
It's going to be dashed. Am I shading up or down? Right? We're looking at this right here. And it's dashed. And there we go. And you said dashed? Okay, and now you said down. So my starting point is the y-intercept, so I'm going to be shading over here. Below the line. Okay, questions? Yes.
So like if you just dash, then it's not or equal to.
Not or equal to, right. Okay, questions? Okay, yes.
I was just going to say, like, once you have y is less than 3 over 2y minus 4, do you change the it's less than sign to an equal sign? Or?
No, I mean, I really don't even change it to an equal sign. You don't have to change it to an equal sign. There shouldn't be an equal sign. Like, by now you should have done a few just to learn. We're trying to tell you it's like an equation. Okay, I'm going to skip this one. And then I'm going to go on to, I want to show you 2 more problems. Oh, don't get confused on this one. We still have to get y alone, right? I switched the terms. Yep. Yeah, my m is 3 over 2. Shh. All right. Sometimes you're given a question like this. Determine whether the point is a solution to the inequality. Don't graph it. Don't graph it. Max, stay present. Don't graph it. Just substitute. Right. Take it. Don't do this. It takes too long. Substitute it in. If it's a true statement, it's a solution. If it's a false statement, it is -4 and -9 make -13. Is that smaller than 9?
Yeah.
So that's true. So the solution is a true statement. Try the next one. Pause the recording and try the next one. Okay, let's try it again. I have no check. Dakota.
It's false.
It's false. I substitute in. We get -6 plus 15 is not, 9 is not less than 9. It's equal. So this would be a false statement. So 3, 5 is not a solution to that equation. All right, now let's look at this equation. Now you're going to write, let's look at this graph. And now you have to write the graph for write the inequality for the graph. So, what do we need in the inequality? We need the m and the b. Okay. Is it going to be greater than or less than? Greater than or equal to or less than or equal to? It's going to be greater than because it's shading above. What's my m? What is it? It's 1 over 1. Agree or disagree?
Disagree.
It's -1 over 1. And what's my b? 3. So what's the inequality going to look like? Annabella?
Y is greater than -1x
-x
plus 3.
plus 3. You get the idea? You want to practice another? This is the homework if you want to start the homework.
Yes, please.
Rami, you want me to also go over number 20? Okay, that's it for our, let me try one more. Shh, oops. Let's try this. I guess that's it for our lesson today.